All right, so this is the second half of the lecture on await and async. All right, so we just talked about how promises modularize the code so that you can basically have one step performed, and then whatever the next step is no longer hard coded into the first step. So the first step only has to worry about how it terminates when it's done, but it doesn't have to hard code to specify what the next step is going to be, which is what a callback function needs to do. With promises, you have the intermediate step of the then, which is the then clause actually does not respond to a resolve. What it does is to specify what to do when in the future it resolves. So, but nonetheless, it does give you the separation of what TB5 has to do versus what TB4 has to do, and we do not need to hard code anywhere within TB5 that TB4 is the next step. All right, so the next step is a much more elegant solution, which is using the title of this particular module, using await, but you can only use await within an async function, and that's why we use these two usually together. All right, so the first thing is we still have the same delay function, that has not changed. What we changed is in main, inside the script, we have one function call to main, and main is an async function. And the reason why we do this is because you can only use await within an async function, and outside of main, I believe it is not async by default. So that's why we would like to contain all the steps within just a kind of function like main in this case. And the reason why I chose the word main is because this is borrowed from C, C++. The main function is the entry point of everything in those two programming languages. So I just kind of borrowed that, but that's okay. Main doesn't really do anything other than being a container of what the script really needs to do overall speaking. So in this case, we can see how we utilize console log to print the 5, 4, 3, 2, 1, and also Thunderbirds are go. And they are sequential. Okay, the statements are now back together, right, quote unquote, right next to each other. They are no longer separated and contained in their own functions anymore, and that's because we can now use await. So what await does is delay by itself returns a promise, and a promise is essentially something, a specification. Basically, it's a specification of an operation that is asynchronous by nature, and when that when that particular operation is done, a resolve is going to be called, and then we can specify, in the previous case we use .then, to specify, okay, what do we do, when resolve is called by the callback function. But in this case, await is simplifying everything, because what it does is whatever promise object is on the right hand side of await, what await does is to say, okay, here's a promise object. I am not going to proceed executing any more statements until that particular promise has resolved. In other words, if you chase down all the links that we have talked about here, it's basically going all the way down to the callback function, because the callback function is the one that is calling resolve. And in this case, await is basically saying, I'm not going to go forward any further until the callback function has called resolve. And as a result, after we print the 5, the program is going to start the delay, but it's not going to proceed any further until the delay 1000, the promise is resolved. Then proceed to print 4 on the console, and then it waits another second, 3 another second, 2 another second, 1 another second, and then finally it prints Thunderbirds are go. So you can see how this logic here is easier to read, because what is sequential, what should be visually sequential, is now visually sequential again. And the best part is we can kind of intermix code that takes a long time to execute, like all the delays, and then all the console logs, which do not take a whole lot of time to execute, can also be interleaved. Using the other approach, the .then approach, that is going to be difficult to specify because it's not like you cannot do it. It's just a lot harder to specify that. So now, section 4 is basically going in to try to explain technically what await is doing and the various ways of using await. So I'm showing you a really interesting program here where there's no await. Okay, and because without the await, it's hard to show when an operation is done, so I have to use this kind of anonymous function here. So you don't have to worry about understanding this part here. Okay, this part is only here so that we can be notified when OP1 is done, and we can be notified when OP2 is done, and we can also be notified when OP3 is done. So don't worry about the anonymous function that is specified as a callback of the .then. So because that's just it's really just eye candy so that we can visualize when OP1, OP2, and OP3 are done. And I also made one more modification. I think I did. Nope, I did not. Okay, that was not needed here. Was basically when each operation starts. So the operation starting would be the same as in this order. OP1 is going to be started first, OP2 is going to be started second, and then OP3 is going to start third. However, OP2 does not wait until OP1 is done before it starts, and OP3 does not wait until OP2 is done before it starts. In other words, now we have the waiter making 3 separate pieces of paper, each one specifying a particular dish to be made by the kitchen, and then the waiter is submitting all 3 orders to the kitchen. I wouldn't say at the same time, but one followed by another. So like, okay, here's the first order, here's the second order, and here's the third order. And then the kitchen can have the flexibility of, okay, I can get the grill going, and I can get that boiler going, and I can get that steamer going, and they can all be happening at the same time. There's no sequential dependency anymore between these 3 operations. But the most interesting part about this sample program is OP1, 2, and 3. They use the delay function, but they are also using a randomness. There's a randomness introduced into it. So that means how much time OP1 takes, how much time OP2 and OP3 take to finish their operation is now slightly randomized. Okay, they're going to take at least 0.3 seconds, and then there's a 0.1 second of fudge time. Okay, basically, we can have 0 all the way up to 0.1 extra extra to the 300 millisecond. And as a result, when you run this program, you will find that between 2 runs of this program, it is very unlikely that you see the same order of completion. So sometimes OP1 finishes first, and then OP3, and then OP2, and other times it will be OP3, OP1, and then OP2. Other times it will be OP3, OP2, and then OP1, and so on. Okay, so this illustrates what happens without the await. Basically, there's no control mechanism of the sequential nature of OP1, 2, and 3. So if you need OP2 to start only after OP1 is done, then this program doesn't do what it's supposed to. Now, it does carry out OP2. It's just that there's no it doesn't wait until OP1 is done. So that ordering is no longer established. And then the next sample program is, okay, there's some explanation, and the second program has it waiting at the wrong places. And this is the one where delay has an extra parameter of name, so that I can actually say, when a particular task has begun, using this particular console log. So in this case, I use OP1, 2, and 3, and this time, when I specify the argument to delay, I have an extra argument to specify, what is the name of the operation associated with this delay, so that it can use the console log in order to print something to the console, which is your terminal, so that we can tell which operation has started or is started at that time. Otherwise, OP1, 2, and 3 remain pretty much the same as before, so we just have some eye candy in this case so that we can tell when a particular operation has started. So in this case, main is kind of interesting, because what we do is we instead of just awaiting OP1 directly, I am using a local variable OP1 promise to store the return value, which is a promise from OP1, and the same thing for OP2 and OP3. So these three are going to be executed in this particular sequence. So we'll have OP1 to run first, returning a promise, and it will be stored here in the local variable. And then we have OP2 doing the same thing, being stored in the local variable over here. And then OP3, we return this promise, and it will be stored over here. So if you recall from our previous discussion, the moment you create a promise, potentially the background task, the background node manager can start the operation already. So that means, after OP1 is called, before OP2 is called, OP1 can start already, may have started already, and then followed by OP2 and then OP3. So now, after I have all three operations started, then I use await on the promises returned by each operation. So I first wait for OP1 promise. So that means until OP1 is done, this is not going to be printed. Until OP2 is done, this is not going to be printed. Until OP3 is done, this is not going to be printed. So what this particular program does guarantee is OP1 is done, OP2 is done, and OP3 is done in this particular order. However, OP1, 2, and 3 are all going to be started, quote unquote, at the same time. And once again, we are not enforcing any specific sequential order between OP1, 2, and 3. Once again, if OP2 depends on OP1 and OP3 depends on OP2, this program is not going to work correctly, because all three operations are started at the same time. It does give you the illusion that they are finished in sequence, but in reality, they may not be finishing in sequence. They only reported finished in sequence. That's the thing, because even if OP3 was done before OP1 was done, it cannot get to the print of OP3 is done until after both of OP1 is done and OP2 is done are printed. So there's no guarantee of the finish time or the completion time of any one of these three operations in this case. And then we move on to the one that works correctly. So the last one, which is using the correct places where to put the weights, we have the same delay definition over here, and the same OP1, 2, and 3. So the only difference between this version and the previous one is how we place the await statements. We have exactly the same statements. It's just the placement of the await. So in this case, OP1 starts and it returns a promise. So right at that moment, OP1 is already in progress. Okay. However, we cannot proceed any further until the promise is resolved. In other words, OP1, whatever OP1 started. Okay, I have to be careful with what I said there. So whatever OP1 has started will eventually call resolve, which is basically saying the promise is now fulfilled. When the promise is fulfilled, then await is going to continue execution to print this. But all this time, OP2 and OP3 have not started. They don't have a chance to get started yet. So this way, by placing await over here, I'm guaranteeing that OP2 cannot start until OP1 is done. Okay, technically, it's until the callback associated with OP1 has called the resolve of the promise. But that's just a lot of gibberish. Okay, the bottom line is whatever operation OP1 starts has to finish before it can get past the await OP1 promise. And because the OP2 call is after await OP1 promise. So that means OP2 cannot start until OP1 is done, and the same thing about OP3. So this is the correct version of the code if there's a dependency between OP1 and OP2 and then between OP2 and OP3. Now, you might be asking, and say, but Tech, you're not supposed to be teaching Node, you're supposed to be teaching us how to do web scripting. That is true, okay? That's absolutely true. But, OP1 can be a database operation, okay? And then depending on the result of that database operation, you may want to do OP2, you may want to do something else, but nonetheless, the data that you're getting out of the database query is what you use to start OP2, which can be another query, and then the result of that query is what you need for OP3. So this is completely relevant to what we are doing, okay? Because we're using Node, we like the efficient nature of using Express, and we also want to enforce the ordering of operations when there are interdependency between the operations, and this is the example of how to do that using Express and Node. So section 5 is basically just a it's explaining why this is relevant and what we are going to talk about next that would actually utilize async and await. Alright, so I'm gonna pause here because even though there's one additional module, I'm not gonna get into that one just yet because that one actually does it makes use of the concepts that are explained here. So before I end this lecture, before I end this particular discussion, one thing I do want to make sure is I do not need you guys to fully understand what is a promise, because the use of promise is actually very, unless you use it a lot, it can be very convoluted. It took me quite a bit of time to understand what it really is and how to use it. Callbacks are pretty easy, but callbacks are a mess. Okay, if you just want to rely on callbacks, your program is going to be so fragmented and it's going to be so brittle, which means if you need to make a change, it's going to break a lot. It can potentially break a lot of things. So callbacks are brittle, promises are convoluted, okay, because the time of setting up something and the time of actually using that something are different, but the syntax, not the syntax, but the name of the methods seems to imply the setup is actually when it happens. The use of the word then, seems to suggest, okay, when one promise is done, then we perform the next operation. When in reality, the dot then is basically setting up the whole thing. It's not really calling those methods within the then. It is just setting up and go like, okay, when this is done, do this next, and then do this next, and then do this next. It's just specifying the instruction. The node environment is what is executing the specification of all the dot thens. So that means it's not very directly visible to you of when are we setting up something so that the background node environment the event loop basically would do it, and when are we actually doing something in my code. So the setting up versus the doing part can be confusing, and what await and async is doing is to kind of minimize that effect. Okay, what you see here is what you get. The only time you have to be really careful is when you call something that is an async and you don't await it right away. It means the operation has already started, but if you don't do the await, then you have no guarantee of continuing execution only after whatever operation you started has finished. So so there is the kind of minor thing about if you forget to use await or put the await at the wrong places, then things won't work the way it's supposed to. But it's a whole lot easier to understand. It's much more intuitive compared to promises and callbacks. So getting back to the bottom line is we are going to utilize node modules that are already supplying async functions. So that way you really do not need to see promises or utilize promises. in this class, we are not going to have situations where you need to store several promises and try to await all of them at the same time. There's a way to do it so that you can parallelize operations when they are when it is reasonable and actually appropriate to have operations parallelized. But I'm not going to get into that in this class, so we are not going to have to worry about that. All we need to do is to completely sequentialize everything in Node. All right, so I'm going to stop this lecture now, and then I'll upload it and then send a link to all of you so that you can actually listen to me explaining these concepts. Now, for those of you who are hands-on, just download the scripts. Okay, every single one has a link to download. So don't click on it. Clicking on it is not going to be very helpful, because if you click on it, this is what happens. It just gives you, the listing where you can kind of copy and paste. But it's easier if you right-click on it and then you specify save link as. You cannot see on the screen because it's outside of the recorded area, so I'm going to try here. So you just go to save link as, like that. And you might also want to configure your browser not to just automatically save it at a certain place, and when there's another file of the same name, it would just append the -1 -2 to the end of the file name. I don't like that. So one way to do that is to go to your browser and then go to settings. And once you get to settings, now obviously this part depends a lot on which browser you're using. So in my case, you go to Files and Applications. This is Firefox, by the way. So you go to Files and Applications, you go to Download. So instead of the first one, which is the default, you click on the second one, which is always ask you where to save files. Chrome has a similar option, and I think Edge has a similar option, and Safari probably has a similar option too. But I like this because this way, if I do overwrite a particular file, I can choose whether to overwrite the file or not, or I can change the name of the file that I'm saving when it is appropriate to do so. Now, once you save the file, you're going to have to transfer the file to the Power server in order for that file to be usable. So you just have to remember to do that additional step. And also your node command to start the script also has to use the file name that you are using. So I'm going to give you an example here. So if I do this, okay, save link as, and I just have to make sure that you can see the file name. You can see the file name here just a little bit. It says post await.js, right? So that means if you transfer this file to the Power server I would put it into your express.debug folder, because these are all kind of sample programs for you to kind of play with. So that means one, you have to make sure that you don't have any app running at the time, because it's going to use the same port as all the apps within the express.debug folder. So you have to make sure nothing is running at the time. And then two, when you start it, you have to say your node and then post await.js. If you don't want to start the debugger, if you want to start the debugger, then it has to be node -- inspect equals to 127.0.0.1:93, and then the 2 digits that are specific to you, and then post await.js. And I don't really see anyone wanting to do this using PM2, because these are sample programs. So you just want to run it, experience it, and then you say, I'm done with it. You know what? I just remember I lied. None of these would actually serve a web page, so it doesn't really matter where you put it. The next module is going to have a program, or 2 programs at least, that you can actually run, and they are web serving scripts. So those you have to be careful where you put it. But these, everything, not just this one, everything in this particular module, none of these is going to serve anything to the web. They're not going to respond to HTTP request. As such, you can put it anywhere. I believe you have a samples folder, from the early discussion of this class. So I would just kind of stash, these sample programs into that folder, and you can just node and then run it. You can always use node dash dash inspect, but I don't really see anyone needing to do that. But if you want to, you can certainly do that too. All right, so what I'll do next is I'm gonna work on the next module, to explain it and also to demonstrate it. And all of these programs, are guaranteed to work because I actually made these work before I put it here. So I strongly recommend people who are hands-on, like to see things work, to try it out. Okay, and you can change the programs too. If you want to insert some additional console.log just so that you can see something, go ahead. Just insert more stuff into the program, if you want to kind of know, okay, I know now I'm at this point and now I'm over here at this point and so on. All right, and don't forget what I said in the previous recording, which is think of a good time for synchronous sessions. So I'm offering, okay, this is my offering to have these live sessions, and I'll record them too, so that way you will have also a recording of the live sessions. So it's a flexibility that I'm offering. You don't have to do it. So if you don't care about a synchronous session, don't respond to the form. It's not necessary. On the other hand, if you want to do it, then you want to kind of find out what time you can make it, and then use the form to inform me so that I can choose whatever time that is most popular. Alright, so I'm going to work on that form now, and hopefully this video helps you understand more about async and await. Now, the internet has plenty of tutorials and explanations as well, so you're more than welcome to also check out additional resources just from Googling. Alright, I'm going to stop this recording.